Welcome to the session on exponentials and logarithms. Logarithms. The objectives for this session are to recognize how exponents and logarithms are related. Exponential functions, recall, are functions of the form f of x equals a to the power x, where a is a constant. The differential is f dash of x equals k times a to the power x, for k a constant. As a increases, k also increases. You will recall that we sketched graphs of f of x equals a to the power of x for various values of a and their corresponding differential function. Remember, this was y equals 2 to the power x and its derivative. This was y equals 3 to the power x and its derivative. And this was y equals 4 to the power x and its derivative. Remember that there exists a value e such that f of x equals e to the power x equals f dash of x, as shown in this diagram here. We are now going to explore inverses of exponential functions. The inverses of exponential functions are called logarithms. So the exponential relationship where a does not equal 1, a to the power x equals n, can be written in terms of a logarithm, or log of n base a equals x. Pause the video and have a go at this example. Press play when you're ready to view the solution. So let's solve example 1a first. We are required to write 5 to the 4 equals 625 as a logarithm. So let's solve this. Now 5 to the 4 equals 625. This has been color-coded so you can see how the two equations correspond to one another. This can therefore be written as log base 5 of 625 equals 4. Here, notice that x equals 4, a equals 5, and n equals 625. And now for part B. We are required to write 3 to the minus 4 equals 1 over 81 as a logarithm. So let's solve this. We have that 3 to the minus 4 equals 1 over 81. Again, we've color-coded so that we can see that a equals 3, x equals minus 4, and n equals 1 over 81. And so this can be written as log of 1 over 81 base 3 equals minus 4. And now for part C. We are required to express 10 to the power 9 equals 1 billion as a logarithm. So let's solve this. Color coding gives us that a equals 10, x equals 9, and n equals 1 billion. So this can be written as log of 1 billion base 10 equals 9. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at example 2a first. We are required to rewrite log of 243 base 3 equals 5 as a power. So let's solve this. Again, if we color code, we will be able to see clearly that a equals 3, n equals 243, and x equals 5. So this can be written as 3 to the power 5 equals 243. And now for part B. We are required to rewrite log 625 base 5 equals 4 as a power. So let's solve this. Here again we can see that a equals 5, n equals 625 and x equals 4. So we can rewrite this as 5 to the power 4 equals 625. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 3a first. We are required to find the value of log 25 base 5 without using a calculator. So let's solve this. Begin by writing log 25 base 5 equals n. Then we can rewrite this as a power. So we have that 5 to the power n equals 25. Clearly the only value of n that satisfies this is n equals 2. Now let's have a go at 3 part B. We're required to find the value of log 27 base 3 without using a calculator. So let's solve this. Write log 27 base 3 as n. Rearranging this, it can also be written as 3 to the power n equals 27. Therefore, clearly the only value that satisfies this is n equals 3. And now for part C, we are required to find the value of log 8 base a half. So let's solve this. Again, write this as equal to n. And as you can see from the color codes, we can write this using the formula for logs as a half to the power n equals 8. And therefore, n is equal to minus 3. Now let's have a go at example 3D. We are required to find log a to the power 7 base a without using a calculator. So let's solve this. Again, write this expression as equal to n, and then rearrange in terms of powers, so that we have a to the power n equals a to the power 7. Clearly, we can see that n is equal to 7. We can also find logs on a calculator. Some calculators have specific buttons to find logarithms, such as the one you can see on your screen now. Logarithms to base 10 are denoted simply as log, and logarithms to base e are denoted as ln, and they are also known as natural logarithms. Now have a go at this example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 4a first. We are required to find log 35 base 4 to 3 decimal places by using a calculator. Let's solve this. Using your calculator, you should obtain 2.565. You can check this by checking that 4 to the power 2.565 is approximately equal to 35. Hopefully these color codes will help you. And now for part B. Find log 23 base e to 3 decimal places by using a calculator. Let's solve this. Using a calculator, you can simply reduce this to ln 23, which will give you 3.135. And you can check that this is true by trying e to the power 3.135, and it should give you approximately the value 23. Again, we've color-coded to help you understand this idea. And now for part C. Find log 88 base 10 using a calculator. Let's solve this. Using a calculator, you can simply type in log 88. This should give you 1.944, and then you can check that 10 to the power 1.944 is indeed approximately equal to 88. Here's the color coding to help guide you through the process. This brings us to the end of this session. If you have understood its contents, you should be able to recognize how exponents and logarithms are related. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.